Now, non-carbohydrate sources, lactate, how lactate converts. So it is not that difficult. Actually, I have already explained in previous class. I will again talk a little bit about this. This is lactate. What is called? This is called Cori cycle. If you know, I have already told you in protein catabolism about Cori cycle. I will explain it again here. So amino acid, how an amino acid converts and propionic acid converts into this glucose. That also I have told you that protein catabolism, and this how this converts. Let's see once again. So you can see the same slide. You can see here glucose. Glucose converts into glucose in muscle when you do exercise. So it will convert into lactate, and this lactate will reach liver, and lactate will convert into pyruvate. So NADH here released, here consumed, here released, in muscle consumed, in liver released, and this pyruvate will convert into glucose. So this is called Cori cycle, or other name is glucose lactate cycle. So lactate produced in muscle tissue will be converted into glucose in liver, the simple. And this is actually the pathway I discussed there. Don't forget this also, Cohill cycle. Actually, during fasting condition only gluconeogenesis happens. And during that condition, what will happen during fasting condition? This glucose will convert into pyruvate, and pyruvate will convert into alanine through transamination. And this alanine will reach liver, and again alanine will be through transamination, it will form pyruvate, and this ammonia will be converted into in liver to urea, and then pyruvate into glucose. So this is called glucose alanine cycle. This happens during exercise, and this happens during prolonged fasting condition. Okay, so remember this gluconeogenesis, it is not absolutely absent in fat condition or absolutely present in fasting condition. So these are fine-tuned reaction by these three regulatory steps. But it will not be wrong to say that it is active during prolonged fasting condition only, not during fat condition, though it is not absolute. Okay, now you already know this, how protein converts into ammonia and then organic acid, and this organic acid actually converts into glucose. So you can understand this, all amino acid except leucine and lysine converts into glucose. Okay, all amino acid converts into 18 amino acid. There are 20, 18 will convert into glucose. And 2 amino acid will not convert into glucose, they will convert into ketone body. And there are few amino acid which also gives ketone body as well as glucose. So these are actually aromatic amino acids: phenylalanine, tyrosine, and tryptophan, and plus aromatic amino acid plus 2. One is threonine and isoleucine. Plus isoleucine. 2 non-aromatic amino acid. All aromatic amino acid will give both. So this is the conversion of amino acid into glucose. So you can see, you already know this. You know the mnemonics here. I have given mnemonics here. So gastric pylorus. So most important is this, through propionic acid pathway which will convert. And you can remember through VIM, Vim. Thomas Vim, you can remember T Vim, Thomas Vim. So Vim is valine, isoleucine, and methionine. So methionine sulfur containing amino acid, branch chain amino acid. These two are branch chain amino acid, and this is sulfur containing amino acid. And this pathway is very important, propionic acid pathway, require biotin and B12. So remember this. And this all amino acid converts into this. So how do you remember this amino acid name? So you can see R-glu and glumine provided for his conglomerate. What is conglomerate? You do artwork by attaching many stones together. You make a artwork. It is an artwork. So conglomerate means alpha ketoglutarate, R, glu, and glumine provided for his histidine, for proline, histidine, glutamate, glutamine, and arginine. This convert into alpha ketoglutarate. And then gastric pylorus. So pylorus is part of your gastric, your stomach. So you can see gastric pylorus. So G for glycine, A for alanine, S for serine, T, 2T, tryptophan and threonine. Tryptophan is aromatic amino acid. Okay. So black means it will provide both ketone and this body. This green will provide only glucose. Okay. So threonine. Here you can see phenylalanine and tyrosine, just one hydroxy group difference there they have. So F for phenylalanine, F for fumarate. So phonetically, F for phenylalanine, F for fumarate, and tyrosine is product of phenylalanine. So this is fumarate. Aspartate, and you already know aspartate is actually amino acid of oxaloacetate, and asparagine is made from aspartate. So easy. And see, these produce this oxaloacetate, and opposite also true. These two are non-essential amino acid. Non-essential amino acid will be produced from this during fat condition. These non-essential amino acid you will see here. What are non-essential? Glycine, alanine. This will provide from pyruvate. Here, cysteine will also be provided from pyruvate. The reaction mechanism is different. This non-essential amino acid, which are the non-essential amino acid here? You will see this non-essential amino acid, glutamine and glutamine. These are provided from this. Okay, and this is also proline is also provided synthesized from this. So two-way process for non-essential amino acid, not for essential amino acid. Okay, even arginine is semi-essential amino acid. So arginine can also be synthesized from this. So this is how synthesis will also happen. Succinate. So succinate will, these are all essential amino acids. So no synthesis, no back reaction. This is also essential amino acid. This is essential from this. So non-essential amino acid will be synthesized from this way. So if you remember this, you will remember many things about amino acid, relation of amino acid and glucose metabolism. So memorize that. Now, how does this glycerol 3-phosphate will convert into this? Because glycerol is, this is glycerol. You know, this is glycerol. Simple. This is glycerol. This is glycerol 3-phosphate. And you can see, and this is dihydroxyacetone phosphate. Dihydroxyacetone phosphate. So what do you think there should happen? So there should be, first one step should be oxidation here, so that it will convert into this. Okay, so you can see here oxidation, dehydrogenation. So this glycerol 3-phosphate will convert into dihydroxyacetone phosphate through this one enzyme, glycerol 3-phosphate dehydrogenase, easy dehydrogenase, and glycerol 3-phosphate, you know, dihydroxyacetone phosphate. How does this dihydroxyacetone phosphate converts into glucose? You know it. So this is very easy process. You can see here. And you know, propionic acid is also synthesized from odd carbon chain fatty acid. Odd chain fatty acid. So don't miss this also. Though this is very rare, odd chain fatty acid is very rare, but you have to remember, okay?